Hey guys, so today we'll talk about how Meta achieves 99.99999% cache consistency. Okay, so just an article, we are going to read through it and all those things. Not that kind of enthusiasm right now today. So let's just create some enthusiasm. So why it matters? A fundamental way to scale a distributed system is to avoid coordination between components. Okay, so cache, what does cache do? It helps to avoid coordination needed to access the database. Why? Because every time you need to go to a database to do something, it's a operation which you have to pay some more money for it. So you cache the data, and how to cache it, that is very important for the scalability. So once upon a time, Facebook was very simple. It was running in just PHP and MySQL. But as many users joined, they face scalability problems. So that they what they do now? They set up a thing called distributed cache. Although it temporarily solved their problems, but they have to solve the scalability issue and all those things. But what is the race condition which uh, can commonly occur? Is like, suppose there is a client, it needs some information. Suppose it needs a value of X and it tries to fetch from the cache. And cache says, I don't have that value. So cache goes to database and try to fetch that value. Suppose that value is 0. Now what happens? Someone writes a new value of X to 1 as 1. Now what happens, like the moment someone writes the value to the database fetch a invalidate operation to the cache, and that reaches first. So now the cache value is 1, but now database also goes and sends the ask value, the response of the fill, and it goes 0. So ideally it should be 1, but now it's 0 because the invalidate operation came first and the response from what the user initially requested came second. So that means the user would have got needed the value 1, but he got 0. Now, this is what it is. Yet their growth rate is very explosive and became the third most visited site in the world just because of the granddads. But yeah, that's okay. So now, how much they serve? They serve around quadrillion, 10 to the power 15 requests per day. So even a 1% cache miss rate is expensive. 10 trillion cache fills a day. So now let's see how we can do or what we do, the cache consistency. So cache or cache inconsistency feels like a data loss from a user's perspective. So they created an observability solution, and here's how they did it. So what they did was they created a separate service to monitor this cache inconsistency, and it called Polaris. So what it does, so database actually do two kinds of invalidation. One is through Polaris and second is through the normal one. And then Polaris also checks the data in the cache. So how Polaris works, we understood from the example, but let's read it out. It acts like a cache server and receives cache invalidation events. That's fine. Then it queries cache servers to find data inconsistency. So it queries inconsistent cache servers and check again later. What does it mean by this? So first of all, Polaris actually act like a cache server, and it also receives cache invalidation events like we see here. Then what it does, then it actually queries the cache to find if there is a data inconsistency, and then it queues inconsistent cache servers and checks again later. So if another time something is there, so it can see the value going wrong or right. It checks data correctness during writes, so finding cache inconsistency is faster. So simply put, it actually measures inconsistency. So beside, there is a risk, right, of network partition between distributed cache and Polaris. So they use a separate invalidation event stream between the client and Polaris. A simple fix of cache inconsistency is to query the database. That's fine. But what is the risk? The risk is that you will have to overload on a very high scale. So what Polaris does is Polaris queries the database at time scale, like 1 minute, after 5 minutes, or 10 minutes, kind of a polling, right? It lets them back off efficiently and improve accuracy. Now, tracing. Debugging a distributed cache without logs is hard. That's right. And they wanted to find out why cache inconsistency occurs each time. Yet logging every data change isn't scalable and it's write heavy. While the cache is for read heavy workload, right? So they created a tracing library and embedded it on each cache server. So how it works? So it only logs the data changes that occur during the race condition time window. Thus, the log storage is cheaper. It keeps an index of recently modified data to determine if the next data change must be logged. Okay, if the recently modified data, right? And Polaris now reads the logs, and if cache inconsistency is found, then it sends the notifications. While absence of log indicates a missing cache invalidation event. The bottom line is Polaris finds a cache inconsistency faster while tracing finds why it occurred. Okay, cache invalidation is one of the hardest things, whatever it is. So now what we read about it is like they do it in two ways. One is monitor and two is tracing. How monitor occurs is that Polaris also try to ping the servers with the invalidation event. It pings it in an interval of 1, 5, and 10. Similarly, tracing occurs. Tracing occurs is like when we do try to trace or write the logs in the file, we only log when we find a race condition that there is a call fill and there is an invalidation. So that time we store a log. Polaris read these logs. If the logs is not present, that means there is a inconsistency. So that's the it. Okay, so great guys, this is the newsletter. I think we'll read more few things. It's just for me, but I am just putting it out in YouTube if anyone wants it. Bye bye.